gonna let this sit for a bit, if just to let people have some, time to jump in. We'll just give it a couple of minutes. I'm not necessarily expecting people to show up, but plus I am a little bit late to the time frame that I was talking about. So, all right. All right, so in our last episode, we saw that when we updated our UI live, right? So let's see this here. We were seeing the update, right? But if we were to load some state into this before that, right? Let's say I want to edit this now and I want to keep all of this state. We were seeing that this now disappears. This is not necessarily what we want, right? So what we're going to do about this is we are going to move things out into essentially being managed by the main application, right? And the main application that drives this entire process is, of course, the decompression UI that we had from the beginning, right? It sets everything up and then it runs this draw here. What we're going to do here is we're going to add some parameters to draw that basically that's the state of our app, right? So I'm going to start by making a type here in our UI kind of thing, right? That we are going to call, let's say, state. That's about as descriptive a name as we need for this because this is the application state, right? And so let's pick something in our UI that we want to put here as proof of concept, right? So one thing is there are two good candidates to me. One of them would be the file name, right? And let's say we have the file name buffer. We're gonna make this a slice of bytes. We can actually see the file name buffer down here is actually an array, right? 256, right? Well, we don't need it to be that, to be perfectly clear, right? Let's now say also that draw here takes a state parameter that is just state, like this, right? And so probably we need this to be, let's say that this is a pointer to state. Doesn't matter too much, to be honest, but now we have put this file name buffer in our state, right? So let's see where we need to change this, right? We have this here, state file name buffer, like this, right? We want to do that here. We want to do it here. Importantly also, this was making a slice out of the thing already, right? And we don't need to do that anymore. It is already a slice, right? So if we save now, we do not have any compilation errors. There is, however, one thing that I think we should take a look at. That can be a little bit tricky sometimes, right? When we were transmuting this here before, we were saying, you know, this is a pointer to basically the beginning of an array, right? But importantly, now we kind of have to do this, right? We're taking a pointer to the first element of this thing and saying that that is a C string, which is fine. So that is something to take, you know, take into consideration here. When you take pointers to slices and so on, you may not be doing the thing that you think you're doing, right? So that is now here. There is one important bit here that I kind of want to do also. I want to take this draw proc and I want to put it here, right? In our UI kind of package, right? This is now our draw proc here. But if I say here now, oh, this UI.drawproc, right? That actually requires us to do this, right? Now I'm importing UI. So now we're actually relying statically on UI as a module, but also dynamically. So now I have this UI drawproc here. This should return a UI drawproc, and so on. And here, if we say drawproc, this should also be this. This is also UI drawproc, and that's all fine. And here we actually want to say state is UI.state, like this, right? And here's why we can have such a kind of a general word for state, right? Because in this particular case, we are saying UI.state, right? Because of course, Odin doesn't do these full imports of a whole namespace by default. So we don't really need to namespace, you know, ourselves, right? I don't need to say that this is the UI state or whatever, right? So here we actually want file name buffer is 256 bytes, like this. We can say this, and then we can say state file name buffer is equal to file name buffer sliced, like this. Now we're going to pass this to draw, right? And so this is just going to be a pointer to state, like this. Opa, too many arguments for draw. What is going on with NeoVim? What do you even want, dude? Like I don't know what that was about, but anyway, drawproc. What is going on here? Okay, so OLS is not OLS. NeoVim is acting very strangely. I'm just gonna quit this for now. Sorry about this. I did not expect to have to do this, to be honest. Let's restart this. Actually, can we just sort of have these in the same one? Yeah, stuff is visible, right? So here we can do task build UI lib watch, and in this one, task decompression UI. Sure. So now drawproc here needs state, which is UI.state, pointer even. Undeclared name UI, oh, like this. And decompression UI now works, or rather it compiles. Whether it works is a different story. Here we will attempt now to load a file name, right? And see, okay, this is now loaded here, right? Let's make a change to our UI now, right? So UI Odin load more. Now we can see that the file name here is now saved. So let's start putting more stuff in here, right? Let's say that we are putting our current frame block, was it? Yeah, we're gonna move current frame block also, right? And let's do this. Let's also say that the data block, the frame descriptor, yeah, let's do those for now. Also current directory maybe. Not that it matters, that one really doesn't matter that much, to be honest. Yeah, let's do these. So in our state, let's actually put, okay, let's put the drawproc down with the state. Opa, here. And now we can say, actually remind me with your errors, dear compiler, frame descriptor is one we want. Okay, let's do remaining data as well. Right, now both of those, so frame descriptor and remaining data are two that we want. Frame descriptor like this, and remaining data, which is this, I suspect. And now when I save this, we're gonna see that, of course, that doesn't solve that problem, but we can do this, right? And this actually applies in both of these places here. Current frame block reader, current frame block we actually also want. So let's do that. Like this. Here we want state dot, of course. 22 errors left, let's go. Remaining block data, did I remove that maybe? I'm not sure. Opa. I did not, okay, so that's fine. Undeclared name block, state dot block, maybe. No. This one is interesting. Why does block not? What did I remove here? Remaining data. File name buffer is removed, of course. Frame descriptor is removed. Current frame block and the block. Right, so I did not add that. Okay, fair enough, right? That's a data block. We're gonna add that as well. block is a LZ4 data block. Of course, this is going to remove a lot of these errors, potentially. Down to 6, state dot. Okay, that's it for this. Now, importantly, we don't know that anything kind of works here now. We will see. Let's see here. So test data, we're gonna load this, right? We are now expecting this frame descriptor block to exist still when we hot reload, right? So now we edit load more, and this persists, right? Likewise, unprocessed bytes in file remains the same. This is not reset. So now we can continue sort of modifying this, right? Without any kind of loss of data of these elements, right? However, this section here may be a different story, right? So let's look at that a little bit. This is in the for write in writes section here. And here we can see we made this green last time, right? That's how we saw that this was different, right? So let's say I'm changing this to red now. Now we can see that it disappears, right? So this is not being saved. So this is in this writes section, right? So writes is of course up here, and we'll do the same process here that we did with the others, right? So we can say writes is a dynamic array of write, right? So, right. Now what we can do is we can, you know, change all of the sections where this is being used, like this, right? This and this. There you go. And here you can see we actually got a seg fault. That's because we're editing the actual memory layout of some of these things live. It's being reloaded live, right? And that's going to crash in many cases unless you set your program up for it. Because memory, of course, when we change memory live, memory layout and stuff, our program doesn't magically know how to deal with this unless we have some safeguards in place. So now we have this, right? We can see now that this is red again. Let's just give this a few goes, and then we can say, you know, I want to for write in writes. Let's change the color here. Let's do blue now. We're feeling some blue. And now we can see that that also works, right? So the process is very much the same, you know, for all of these things, right? We really only need to put things in a place where they are not being kind of reinitialized by our reloaded code, right? Because the main issue here is, of course, before was simply these statics here are initialized by our constantly reloaded code to be certain values, right? There are 0 values, there are constant values, and so on. That is simply not something we can do if we want this to persist, right? So with that in mind, basically at this point, it becomes just an issue of the stuff that should be reloadable, right? Or persisted rather, is not here, right? It's not initialized by this code at all, right? So with that in mind, let's just take the remaining stuff and put it there and see kind of what we can do then, right? So output here is, output is interesting, right? Because this actually is fine, except if I load more now, I would guess that this doesn't work. Yeah. So the fact that, so output is being used here as a kind of a temporary buffer that we use for other things, just to be clear. So in order for it to, it needs to be persisted so that we can actually click load more again and have it work, right? So let's do that as well, right? Output is a slice of byte. Let's also do file picker stuff. File picker open is a bool. File picker is a file picker, like this. Current directory is a string. This means also we don't need to initialize this here. Remaining block data, copy index. This is really just sort of, we're just doing this over and over, right? It's really fairly straightforward. State.output, state.copyIndex. State.copy bytes is not a thing at all. Down to 11. This is really just, again, you know, we're just doing the thing over and over, which I don't mind at all. A lot of people, their first instinct when something like this is happening is, oh, well, there's a way to do that better, right? To do that more conveniently or something like this. That is optimizing for the wrong thing, usually. You genuinely do not need to optimize stuff like this away. People who think they do, generally speaking, I think they're just not solving problems, really. It's tempting to think that you're solving problems by, you know, always focusing on, oh, we have to write as little code as possible and stuff like this. It's just not a thing. That is not the problem, generally speaking. One thing that I want to do now, because if we start our app now, we'll see that we are probably, our file picker doesn't work. And that's because we don't have the right current directory. So we do want to initialize that in a certain way. So because the main application now is responsible for initializing things, right? And some things are going to be correct. They were basically already 0 values, right? So, but state current directory is going to be os get current directory, like this, right? And once we've made that change, we actually will be able to open our file picker and it works just as we expect, right? So now we have this content here, and if I reload, or rather, you know, we let it reload. Let's put that away just for there. Load more. This is my go-to. I just search for this and change it, right? Now we can see this is now persisting and so on. Everything seems to be working. Now let's try to load more data, right? And we can, right? So now we've kind of persisted essentially every variable that we previously had just sort of static, right? In our UI draw function. We've persisted that basically outside, right? All this is doing is rendering, and of course it can change things, right? Because that's the nature of an IM GUI interface. But at the same time, we're basically just using it as it just draws the things, right? It's not responsible for the state. Sorry. Let's just say 0, 0, 1 here, because I want to experiment a little bit here. Purple is nice. Purple pink-ish. Yeah, let's leave it like this. I'm liking it. Here we can also try with this. I'm curious. Yeah. It is very nice, right? I mean, very nice might be a stretch, but you know, I like it. So yeah. I mean, honestly, this is kind of the episode, if I'm being honest. Like, I didn't think that this would maybe take such a short time, right? I thought maybe that we would have some kind of roadblock. There's usually a roadblock or two. Because I'm doing this live now, I kind of, you know, expected this to maybe have a few bumps here and there, right? But the theory behind this is fairly simple, right? So let's go over what that actually is, right? I'm gonna just leave this to the side here. Right, so the theory behind this is very simple from the perspective of what we're doing, right? In our UI here, all we're actually doing is we're saying, give me a piece of state. I'm going to try to work with that state. I'm going to draw that state and I can modify it and so on. But it's well defined and it has these things inside of it, right? It has all of the things we were previously doing, but what we were doing them with statics. So they were initialized by us, basically. They were basically initialized once for every draw function, right? Not per call, right? Because if you have a static like this, right? If you have a static like this is an integer, right? Basically the first time this runs, this code here, the first time it happens, this is going to get initialized, right? But if I had, for example, we could have this code here, right? This is not going to initialize it to 0 and +1 every time draw is called, right? It's only going to initialize to 0 once, and then we're gonna get a +1 for every draw call, right? So it looks as if this should basically be always 1, right? But it's not, right? However, when we reload a library with this draw function, we have technically a completely different draw function. So it is reinitialized every draw. That is how we lost state, right? So we were losing state because we had these statics, right? And statics are nice, right? However, in this particular case, we want to essentially have someone else manage this state, right? And basically say, you know, I'm just drawing the state, so it's not going to disappear on us, right? So with this, now we have this, we're being passed this state here. We can now just draw it like this, right? And you can use this fact in your UI, in perhaps a server process or whatever it might be, right? Have some thing that we can reload, like a function, right? For example, you can have your HTTP handlers be defined in a shared library, for example, right? And when you want to reload these HTTP handlers, the main kind of web server, right, that sort of handles all of the actual sending of bytes and so on, that's just sort of, it's possibly maintaining state for you, right? Of course, HTTP is a little bit of a different story. You don't necessarily need to be super stateful, right? When you're doing HTTP, it's very much request in, response out, right? But, you know, at the same time, persistent services and all of those things, right? So, this is basically kind of what I was planning on showing today, that this problem of, oh no, our state is disappearing is really just because of, you know, this. We are getting new initializations when we reload new code, right? And it is because of reloading that code that we are, you know, ending up in that situation. And we want to reload code, so what's the solution? The solution is simply, you know, maintain the state instead. Be past the state, use it, change it, that's fine. Changing it is why we have this pointer here, right? Let's say I were to remove this. we would see immediately that, first of all, we can't take pointer addresses, right? Also, I can't assign to state file picker open and so on, right? So we do need a pointer here. A pointer in Odin doesn't only signify that this is going to be, you know, an address of something. It also signifies, it signals to the readers of the code, we want to be able to modify this thing, right? And of course, in many cases in C code and so on, that is effectively what that does as well, right? It does signal I want to modify this, or I'm going to modify it. Or if I have a function that takes a pointer, we take a pointer to state simply so we can actually assign to all of these fields, these subfields of state. We're not changing the pointer itself ever, right? But all of these fields we're assigning multiple times and so on. And this is how that actually flows through our application, right? So, are there any questions about this that sort of pop up? Because I'm unclear. It's unclear to me, sort of, you know, what people are wondering about when they see this, to a large degree. How long have we been live? 30 minutes, 32 minutes. So yeah, not that long. Like I said, I expected this to take a lot longer. But yeah, we could of course try to do more here. Absolutely, we could. I was hoping that the next episode we would try to focus on basically putting a new panel here. So the panel will basically be the data that's associated with each frame down here. So you can click on these frames. Right. Yeah, this episode, or you know, what we did now will basically show you a way you can do persistence. Yeah, absolutely. This should be very useful in that case for you. Yeah. But again, I did not expect this maybe to go so fast. So now I'm a little bit at a loss for what to do. But it is not a very difficult problem. The idea behind this is fairly simple, right? And also, one change we actually made in this particular episode is also, before we were completely decoupled from our UI code, right? Our UI.draw kind of code, right? That module. Now we actually import that statically, but only for the types and so on, right? We don't call draw from UI, right? Because that would of course be static and we can't actually reload the code. But we are using the types, right? And this is a very useful thing, right? Because then the UI package can define these types, right? What is a draw proc, for example, right? What is the state that you're passing me? Which means when we make a mistake, right? That's very easy to catch, right? So for example, our state variable here, if we were to try to set something completely bogus, you know, bogus to 0 here, this wouldn't work, right? Because we have proper type checking and so on, which we actually did not have before. A draw proc was defined entirely in both places, right? Whereas now we have this shared idea of what is the state, what is a draw proc, and so on. Hello, Stanya. So yeah, obviously I was late, by the way, a little bit late, 20 or so minutes to the stream window. But yeah, actually we can kind of jump, I guess, ahead now to looking at some of these additional things. So again, what I was talking about here was to have a panel that shows when we click one of these frames, what is the data associated with that frame, right? And there are a few things that go into this. One, we need to modify the code that actually pulls the frames out to give the byte information as well. And two, I think we need to change the panel actually, because actually I will illustrate this, because I'm fairly certain that the panel in draw panel here if we were to have two of these in one place, it would look bad. So let's just draw the same panel twice, and I think that will illustrate what's going on. Okay, so the stream is better today. Yeah, because yesterday I saw that it was lagging and so on, and I was a little bit confused, like why is this, right? The irony here is that the bitrate I'm using is essentially the same as my third test yesterday. Of course, I did a lot of tests, so you may have seen some of the previous ones, which were, the bitrate was completely insane. Maybe YouTube was having problems. I don't know exactly what happened, but yeah. So here we can see now that if I do same line here, we're actually not getting the same line at all. In fact, I'm supposed to get this panel on the same line as the one we had before, right? But it's as if I called it like this, right? And so same line here should actually place this now to the right over here, right? But it doesn't. So there are a few things we need to kind of fix here with the panels, right? And I want to get into doing that. So let's see here. I think one of them is fairly easily solved, begin group. And here I kind of want to do defer end group. This may or may not, it might not work. Let's see. Okay, so now we're placing it in the right place, right? Ish. You can see here that these are overlapping, and that's not super great, right? We want to fix that. Generally speaking, this will depend on having dummies in the right places. Here we might actually say this, perhaps. It's basically always a good idea to have Erlang in the backend. So, I mean, okay, yeah, let's not take too much time away from this, but because we're now on bonus time, as far as I'm concerned, I was only planning on doing this, keeping state across, but Erlang on the backend is always a good idea, pretty much, right? As long as you have something that justifies kind of the liveness, right? Erlang for live systems with potentially many clients is almost always a good idea, right? So if your system, if the thing that you're doing could be compared to live betting, for example, right? So we're talking near real time, right? Because of course it's not real time, we're not talking about, milliseconds. Many users, they all want approximately the same information at approximately the same time, always, right? So probably, tens of thousands of people are interested in one thing. They want live updates about that thing. They want to interact with the thing, and when they interact with the thing, everyone else should know about it at approximately the same time, right? This would be effectively Erlang's, highest value use case, right? And that is definitely appropriate. A lot of games fall into this, right? I would say that there are certain things, in the game that I would use Erlang for, right? So when I worked at Creative Assembly, right, we were using it actually also. This, I don't know, is this visible? Yeah. This is a poster from a game that I worked on at Crytek, a company called Crytek. This was a LOL clone, believe it or not. It wasn't super good. Anyway, so those games, right? We were using it for things like setting up matchmaking, lobby systems, right? So for example, the system that actually manages the chat, right? The system that connects players to each other, the system that allows people to add people's, to their friends lists, or they make a custom game lobby, everything that happens before you actually get into the game, right? For example, right? So if you were making Dota, for example, everything in the menu would be basically driven by Erlang in this, hypothetical scenario, right? And so, yeah, most things in games that are, live sort of systems would be appropriate uses of Erlang, in my opinion. But, that doesn't mean you can't use something else. But definitely Erlang is good for this. And by extension, Elixir is good for it, right? So there are differing opinions on whether you should use Elixir or Erlang, I suppose. Personally, to me it doesn't matter so much, but I prefer Erlang as a language. It's just that Elixir has a lot of neat libraries. The standard library is better designed and so on. But yeah, Erlang is good. I mean, for backend stuff, it's definitely good. That doesn't mean you can do everything you want in Erlang, right? It is slow. You don't have any insight into how the cache behaves, or, when you define data, it's not like you're defining the data with, you can know exactly what the byte size of something is going to be just by looking at it. No, you have to know a lot about the platform, how it does things, and so on. So it is not for performance work. It's very kind of opaque, I guess I would say. It's not particularly good for performance stuff and so on. Elixir and Erlang, it's always worth learning these types of things, right? They have very unique threading models in comparison to everything else, right? So one of the key things in Elixir and Erlang is that they have a preemptive scheduler, right? So if anyone has sort of knows anything about schedulers and so on, in operating systems, right? The operating system basically makes it so that for some definition of fair, right? The scheduler is fair in that it allows everyone to do their work, and then it sort of says, you've done too much. Someone else is going to do something right now. Another process is going to work for a little bit, and then we're going to deschedule that, and so on and so forth, right? That's a preemptive scheduler. Most programming runtimes have what's known as a cooperative scheduler, and some of them have semi-cooperative schedulers, right? So, for example, if I just make I'm not sure about the specifics here, but for many languages, right? So, for example, something like C# or something, if I'm not using async and stuff, we would be basically having to say when we can be descheduled, right? Otherwise, our thread is just going to do work until it's done, right? And if, let's say you have 4 cores, 4 potential threads, right? If I do 4 of those things at the same time, nothing else can do anything, right? Until one of them is done. And then the next thing can do some work and so on. That is definitely what we would end up with, for example, in Odin, if we use certain things and so on. So what Erlang does instead is that it basically has a system where you have sort of fuel, right? These are called reductions. So whenever you call a function, that's effectively consuming fuel, right? And when your thread, when you are out of fuel, the scheduler is going to say, okay, you've done enough. I'm going to let someone else work for a little bit, and so on. So anything that is intensive, like work intensive, is going to be descheduled, right? So it's a fair scheduler, meaning we can't actually, one user of a web service that's written, potentially badly or does something heavy, that user can't actually do 4 of those things, and now no one else can do anything, right? There are a few very, very small exceptions to this rule, but generally speaking, that's how it works, right? So yeah, the preemptive schedulers are fairly unique in the programming space. Golang actually has a semi-preemptive, semi-cooperative scheduler. Go basically inserts these gates whenever there's a function call, right? Ooh, sorry. And these gates are points where you can be preempted, right? So between these function calls, Go is going to insert these and so on, right? But importantly, this does not apply to while loops and so on, right? So it's more like whenever we do a function call and so on in Go, we have the capability or the possibility of being descheduled fairly, right? So it's a semi-preemptive scheduler, semi-cooperative. I don't know what they call it necessarily, right? But this is basically the principle. And so these kinds of things kind of in some ways they change what you can do, right? In Erlang, you don't particularly care that you're doing something that is potentially blocking, right? Because the truth is that blocking operation is simply going to exist and we're going to be descheduled and it's fine, right? We can wait for a long time for a message because the only thing that's happening is that we are effectively spinning around in a while loop, but the entire thing can be preempted at any time. So it doesn't really matter, right? And so this is one of the things that I think makes Erlang and Elixir very unique in that way. Certainly in the practical space, right? There's almost nothing that works like this. Outside of maybe, I don't know. I'm fairly into languages. Like I know of many of them, and I know many of them. Like I've used them and so on. But to me, there's almost nothing that I know of that works like this outside of Erlang and Elixir, right? Of course, like it's the Beam that works like this. Just to be clear, it's the actual runtime of this, the Erlang runtime, right? That's the thing that actually works like this. So just to be clear, it has nothing to do with Elixir as a language, right? Elixir is just a set of libraries on top of Erlang, right? So from that perspective, it's, I don't want to give the impression here that Elixir has sort of added anything to this or, whatever, because this is already an impression that people have. But Elixir is just a syntax on top of Erlang with some libraries and so on. And, let's say cooler people, right? Which is neat. That's fine, but yeah, anyway, I have probably ranted too much, I feel like, but anyway. No, it's not, yeah, just to be clear, it's not about that, by the way, or like I'm not trying to give the impression that I got super sidetracked. I'm well aware of what I'm doing, right? I am very prone to ranting, and that's fine, to be honest. This is a live stream, so I would rather kind of interact with you guys anyway, right? The videos are also neat, right? But the truth is we did the thing that I came here to do, right, before that rant. So from that perspective, if I did the video and then I came here to rant, that would be effectively the same thing, right? So let's not worry too much about that, though. It's fine to have fun and, whatever. So here I want to, okay, we have this end group here, right? We have now sort of grouped this so that we can, actually it's not clear to me which one is causing this behavior. Let's draw panel rather, sorry. Draw panel. Let's replace this just for the time being with some text, because we'll see much more clearly, what is going on. Right, so it's the left item maybe that is stretching out to some degree. No. We want the draw panel to be the thing that does this, right? So let's see what we can do here, right? Clearly this is not going to do the thing, right? Because what I was thinking now was adding padding inside of this group shouldn't do anything, right? Should it? Like if I was to do this, no, that doesn't change anything. And clearly, like if I do padding and this will not do anything. Actually, the only thing that did was push content. Look at the live reload. This pushes content down. But hang on, surely this is XY, no? You would expect. So if I do this now, yeah, the second one is Y. But this dummy, okay, I'm not getting it, I guess. I don't know why this, because this pushes content even though it's in the X. Yeah, not clear on why that is. Anyway, let's not focus on too much on that. So we have here, we did this begin group. We have this end group here, right? It is after this that I want to push content to the right. Probably. We want to push it padding size, right? But that doesn't work. That doesn't work because okay. I still don't understand why this second one is. Why would that be? This is massively confusing, isn't it? Am I crazy? Like, this should be an X. This is X and this is Y, right? When you remove this one, you actually pull content up. Why? And that is exactly what I mean. Why? It's in Y, the Y axis, even though this should be in the X axis. Because this is the one that should be modifying the Y position, right? We're basically putting stuff, you know, when we have this code, we push it out, right? Which is what we want, right? Anyway, so now I've added this, right? On the same line as this, actually here we can do same line EX. And the reason we do use the EX version here is because we can actually specify, like, is there any extra space being taken, right? So that's actually a good thing to look at, generally speaking, right? So what I mean by this is, generally speaking, if you have these kind of abstractions, right, like draw panel, you kind of want them to work consistently and You don't want to add extra space that's not been asked for and so on. And in this particular case, we have this padding that we want to control things with, right? So that's really, the thing that should control this stuff, not some extra stuff added by same line, right? Here, however, between two elements that we have in our normal UI section, it's completely fine to have some extra space because it's all about how does it look, right? Anyway, let's try to use draw panel again and see what we actually get. Now we actually get two panels that kind of look normal next to each other, right? And this is what we wanted, right? And so now I think we're kind of ready to start drawing maybe more stuff, right? And by the way, I have to say, I'm really, really liking so the fact that we can now live reload everything, right? This has been such a nice thing to have, right? So what I actually did with the thing that I want to implement where we click on some frame content here when we get this up here, I did a very, very small proof of concept of part of that, right? And it was really, really hard to kind of work on, right? Hard is maybe a bit of an overstatement, right? But that's why I came up with, we should really add hot reloading, right? Because working on UI stuff in particular, to me, it's sort of like you get spoiled, right? And hot reloading is such a nice thing to have for something visual. Like you want to update your game, well, do it live, you want to update your UI, well, just do it live, reload it, right? And this is why I wanted this stuff. This has been such a nice thing, right? You just sort of, you comment something out, you write something else, bam, it's just there, right? I mean, how nice is this? It is so much better, right? You don't have to restart anything. We can kind of just look at the code. We can look at the UI we have. We can look at the code more and so on. I don't have to switch to some terminal window. Like this is how it should be. And I'm really loving doing this right now. This is super nice. So now we have two panels, right? So we fixed the kind of padding issue with drawing these panels and so on. What do we want to do now? So my idea, we have been going for an hour. I'll be honest, I can't implement the thing in its entirety in time, to be honest. I will, however, explain kind of what I want to do and what I guess the next live stream will be about. Next episode, it depends on what people want. When I click, for example, on this here, right? What I want to see here is a hex representation of the data that is associated with that particular data block, that sequence, right? So remember, LZ4 frames they consist of basically data blocks, right? These data blocks have just a bunch of bytes, and when you read these bytes, you get sequences, right? So one sequence might say, for example, output the literals, square, package, LZ frames, etc., square bracket, new line, test, and stop there, right? And then it will say, go back to here, right? And copy underscore frame, right? Like this, underscore frame. That's what this purple is about here, right? So that's one sequence, right? And that is just a bunch of bytes, right? And when you want to diagnose this, generally speaking, what will happen if we, actually, let's open a new one here. Generally speaking, when you diagnose this stuff, what you actually end up doing is you end up with this here, like this, right? And there's no problem here from the perspective of, can I see the data and so on, right? Here you can see that these frames that I'm talking about are starting, right? So here it's saying basically, I have a bunch of literals for you. The literals are, and then it says this, right? And then it stops at test here. And then it basically says, hey, go back some amount and copy underscore frame, right? And when you are diagnosing this, right, you end up looking at these hex values and so on, right? But what I want is for those hex values associated with that particular sequence, when I click on the sequence, right? Or when I click on _frame here, because it's part of the same sequence, right? I want that to show up in a panel here, right? And that's what we're going to be doing next time, right? We're going to throw up a hex view of that data, right? Probably in groups of 8 or something like this, you know, classic like this, you know. This is, by the way, dhex. It's a neat program. If you want to use it, you can actually search for, you know, search for patterns and so on, right? So, for example, if you're looking at a file and you're kind of wondering, where is everything stored in this file, right? If you search for 0422 4D18, for example, you set it to forward and you say go, you actually, you're searching for what is the start of an LC4 frame in a file, right? And here it might seem, oh, this is, well, Ricardo, you can see the start of the file is the start of the frame, right? And that's not always the case though. So for example, if we go here, let's see here, tools, BG3, mods, bags. So if we search for the same thing now, let's see, 04, hang on. Oh yeah, I'm messing up now entirely. There you go. 0422 4D18, I want to say. Let's see. Let's see, 4. This is all specified, of course. Here you can see this 0422 4D18. Was that not what I? Let's see. No. I messed up. 0422 4D18. And of course the direction here is opposite, right? This is a little endian value, but we still write it the big endian when we write a number, right? So what you actually have to do is you have to go from the back, right? 0422 4D18, right? Like this. There you go. And now in this file we actually have LC4 frames, right? This is a mod for Baldur's Gate 3, right? But they store the mod data in LC4 frames, right? So they can extract them, right? LC4 is it's incredibly, it doesn't take much power, right? In terms of, it gives you fairly reasonable compression, but it doesn't actually consume a lot of resources. It's very fast and so on. You can get very good output speeds with LC4. So that's why they're using it as part of their, you know, pack format. So usually when you see a pack format, it means the company made up their own format, to be honest, right? It's not a standard thing. I mean, as far as I'm aware. And so you will really have to kind of explore this yourself, right? And I found out that basically Baldur's Gate 3 mods are using LC4 frames inside of their content, right? And one interesting thing about this, right, is that LC4 frames, they don't actually support any kind of, there are no file names, right? But if we look at this file, what we actually find is that there are file names and so on in this file, right? In fact, there is some level of kind of other stuff inside of this file that sort of identifies these things inside of the file, right, and so on. And so, yeah, things can have these frames inside of them, right? That's why we have this these bytes, right? And also we can have LC4 being streamed over the network, right? And when we see these specific bytes, we know that a frame is starting, so we know what to expect, right? So we can stream LC4 fairly easily using this fact, right? But yeah, so the idea for the next stuff is this panel here with content, right? Probably will be, you know, larger like this, right? We're only doing this now because, of course, I want to work on this while having this open, right? And so on. So yeah, that will be the idea for next time. Are there any questions that sort of have popped up? I know we're only one person left now, but yeah. Barely, maybe. No, I'm gonna take this silence maybe as, you know, there isn't anything that has come up. But yeah, probably gonna have to edit this, I suppose. I'm not sure. No, actually, I'm probably not gonna edit this if I'm being completely honest. It is a lot of work editing videos, and I'm not super up for it if I'm being honest. As you haven't probably noticed, the videos on the channel aren't exactly editing masterpieces, we'll say, right? So we have done this now. We've done the panel. We have some nice padding here in between, and even if I did now same line and I drew a third panel, we should be seeing that this this behaves correctly, this does behave correctly, and so on. I feel good about this. This makes sense now. However, we're gonna remove that for now, and we will maybe commit some of this code. Draw proc is now defined in our UI code. We have removed all of the statics. And again, it was the statics here, the static initialization that was screwing things up, of course, because they were being continually reinitialized whenever we loaded a new version of the library, right? And that is, of course, what we're trying to avoid. And so here we are really just making mechanical changes because we put things in state, right? And this is the code that deals with the panel. Here I see that we have some dead code I'm gonna remove. Okay, I guess that's it for now. And well, with that, have a nice day and ciao.